So now we have an example where Summer is considering the expressions of 2 times the quantity of 3x plus 20 and 1/3 times the quantity of 6x minus 12 plus 4 times the quantity of x plus 11. There are 2 parts to this question. Part A is that Summer claims that the first expression is greater than the second expression for all values of x. So we want to see, is Summer correct, and explain your answer. So we need to decide and see, are these expressions really, is one greater than the other, is one less than the other, or are they equal to each other? So we can then compare it and see if the first expression is greater than the second. So in order to compare them, we're going to set up our expressions with a question mark in between them and simplify them. The first expression to simplify will multiply 2 times 3x and 20, so you're distributing the 2. That gives you 6x plus 40. In the second expression, we're going to multiply by 1/3 and by 4 when we distribute. So that will be 1/3 times 6x is 2x, 1/3 times negative 12 is negative 4, and then 4 times x is 4x, and 4 times 11 is 44. We'll then combine like terms of 2x and 4x to get 6x, and negative 4 and 44 to get 40. So now we're comparing 6x plus 40 to 6x plus 40. We can clearly see that they're the same expression, so we can replace the question mark with an equal sign. And so therefore Summer is incorrect. Remember, she said that the first expression was going to be greater than the second expression. So now we can see she is wrong. So now for part B, we want to write another expression that is always less than both of these expressions. So since both of the expressions simplify to 6x plus 20, we can write any algebraic expression that simplifies to a 6x. It's a coefficient of 6 with the variable x, and any number less than 40, because again, we want the expression to always be less than both of them. So we can have, for example, 6x plus 20. Again, we have the variable x with a coefficient of 6, and we have the number 20 is going to be less than 40. And then we can get a little fancier, and we can have 1/2 times the quantity 12x minus 10. So at first, it looks like 12x is not the coefficient of 6, but if we distribute the 1/2 to both terms and simplify that expression, we get 6x minus 5. So 6 is that coefficient we want, and negative 5 is less than 40. So again, you can find any expressions by comparing them. This one was less than, but let's say you want an expression greater than both of these. Well, then again, you'd still want that coefficient of 6, but then you can have that constant be greater than 40.